Watch this. I'm going to request google.com. Boom, my traffic exits through Germany. Now, without changing any settings, I will request facebook.com. Now I'm exiting through the Netherlands. And finally, I will visit a government website. It connects directly. No proxy, no detour, no triggering geo-based protections. I didn't touch a toggle switch. I didn't disconnect a VPN. This is Xray's intelligent routing engine. It doesn't just shove all your data down the tube. It makes split-second decisions on where every single packet should go. Today we are going to build this logic step by step. Welcome back. In the last video, we built a basic proxy chain, a simple tunnel from point A to point B. But if you stop there, you are missing the real power of Xray. Today, we are moving from just working to mastery. We are going to configure the routing engine to split traffic based on domains, countries, and protocols. By end of this video, your setup won't be just a proxy. It will be a smart traffic controller that decides how you connect based on what you are accessing. Before we touch the config, we need to answer a critical question. Why do we need complex routing? Why not just tunnel everything? To understand this, we need to clear up three terms that people confuse: privacy, anonymity, and censorship circumvention. Xray is a master of one, but not all. Privacy is about data, specifically limiting data collection. Think of privacy like closing your blinds. You don't care if people know you are home, you just don't want them to see what you are cooking. Tools like HTTPS, encrypted client hello, encrypted DNS, and ad blockers protect your content. A standard VPN protects your data from your ISP, but the VPN provider still knows who you are. Anonymity is about identity, specifically about hiding who you are. Think of anonymity like wearing a generic mask in a crowd. People see that someone is there, but they have no idea it's you. The best example is the Tor project. It bounces you through 3 nodes to scrub your identity. Xray is not Tor. If you need to be a ghost, use Tor. Censorship circumvention is about camouflage. This is where Xray shines. This isn't about hiding who you are, it's about hiding what your traffic looks like. A standard VPN is easy to spot because it looks like a tunnel, a single heavy stream of encrypted data going to one server. To a deep packet inspection firewall, that looks suspicious. It looks non-human. Firewalls don't just block, they profile. Consistent encrypted traffic to a single endpoint 24/7, that's a pattern, not a person. Here's the reality. If you shove all your traffic, YouTube, banking, local news, and restricted sites through a single encrypted tunnel, you create a massive, obvious fingerprint. Xray routing engine allows you to blend in. It lets you say, send Netflix through the local ISP so it's fast, send my banking directly so I don't get banned, but route my Telegram traffic through an encrypted server in France. By breaking up your traffic streams, you stop looking like a VPN tunnel and start looking like a regular human browsing the internet. You aren't just hiding, you are managing your digital footprint. So if your goal is just blocking ads, Xray is overkill. A simple DNS filter like Pi-hole is enough. If your goal is basic privacy from your ISP, then encrypted DNS or maybe a standard VPN is enough. But if your goal is beating aggressive firewalls and deep packet inspection, this is exactly what Xray was built for. So let's open the dashboard and learn how to architect this. Last time we built a simple setup. One inbound, one outbound. All traffic that you send to the HTTP inbound is forwarded to the remote proxy over shadowsocks protocol. That remote proxy handles the connection to the internet and the DNS query. This prevents DNS leaks, ensuring your local ISP can't see which websites you are trying to visit even before the encryption connection starts. However, there are a few issues with this approach. First, one tunnel equals one fingerprint. If all your traffic uses the same server, same protocol, same timing patterns, then DPI sees a single encrypted stream. Constant activity. It looks like a tunnel. Moreover, some traffic should not be proxied. You don't want your local LAN traffic or your banking application, which might flag you for logging in from a different country, going through a proxy. On top of that, using a single proxy is a single point of failure. So single tunnel is easy to detect, can be unreliable, and just does not look real. We need a smarter way. To solve that, Xray allows you to configure multiple inbounds and multiple outbounds. Last time we've done the proxy configuration via command line, so this time let's try 3xUI, a web-based GUI designed to manage Xray. It's running on a VM inside my local network. First, let's go to the inbound section where we define how traffic enters our proxy. I will create new inbound. Let's set the protocol to HTTP and name it HTTP in 1. I will leave the listen IP blank, so Xray will listen on all interfaces. Let's set the listening port to 1080 TCP. Finally, I will remove the credentials. Keep in mind that in a real-world production setup, you should always use a strong username and password to prevent unauthorized people from using your proxy. Let's click Create. Okay, now let me create another proxy. I will set the protocol to HTTP, call it HTTP in 2, set the port to 1081 TCP, remove credentials and click Create. We should now be able to connect to the proxy from within the local network using TCP ports 1080 or 1081. Let's look at the underlying configuration. You can export the inbound parameters, but the actual Xray configuration is available in the Overview tab under the Configuration button. One thing I'd like to mention is that 3xUI automatically assigns a tag to every inbound. A tag acts like a label that can later be used in the routing system. Keep in mind that if you configure Xray via CLI, you'll need to assign the tag to an inbound yourself. Let's now head to outbounds. This is where you define how the proxy connects to the outside world. I will add a new outbound that connects to a proxy in Germany using the shadowsocks protocol. Let's set the tag to shadow.dat, then specify the remote IP address and port. Next, paste the password and set the encryption method to chachapoli. Now let's add another outbound, this time to a proxy running in Netherlands. I will set the protocol to shadowsocks, assign the tag shadowNL, enter the proxy IP and port, paste the password, choose the encryption method and click Add Outbound. If we go to Advanced tab, we'll see the underlying Xray configuration for the outbounds. Note that each outbound has its own tag. Now we have 2 inbounds and 2 outbounds. You may ask, how do I control which traffic goes through which path? That's where Xray routing comes in. Routing is where Xray stops being just a proxy and becomes a traffic control engine. It decides which outbound handles each connection. With routing, we can separate traffic, so different traffic uses different exits. Different outbounds mean different encryption, different countries, different behaviors. We can say this goes direct, this stays local, this uses proxy A, this uses proxy B, and so on. Routing lets you send UDP traffic via one outbound, HTTPS via another, quick somewhere else, or block some traffic entirely. This is very similar to firewall rules, but at the application layer. Let's start with a very basic example. We want all traffic coming in through HTTP in 1 inbound to be sent to shadow.dat proxy, and all traffic coming in through HTTP in 2 to be routed to shadowNL proxy. To achieve this, we'll use routing rules. Let's go to the routing rules section and create a new rule. As you can see, there are many ways to match traffic: by source or destination IP, by port, by network or application protocol, or even by domain name. But for this example, we'll keep it simple and use tags. Anything that comes in via the inbound with tag 1080 should go out via the outbound with tag shadow.dat. Now for another rule, anything that comes in via inbound with tag 1081 should go out via the outbound with tag shadownl. Let's go to the Advanced tab and click Routing Rules. This shows how the underlying Xray configuration for routing looks. After that, let's save the configuration and restart Xray to apply the changes. Now let's test it. We'll use ipinfo.io to get the IP address that sent the request. First, using the inbound on port 1080. The request was routed through the proxy in Frankfurt. Next, let's try the other inbound on port 1081. This request went out via proxy in Amsterdam. How cool is that? Just keep in mind that routing rules are processed top-down, sequentially. The first match wins. If no rules matches, Xray will use the first outbound by default. That's why it's important to structure your rules from the most specific to the most general. Let's look at another example, routing by domain. With an HTTP proxy, the browser includes the destination hostname in the connect request, so the proxy knows where to connect. Xray can then look at that field and make a routing decision. When routing by domain, it does not need to resolve DNS or know the IP address. It simply uses the domain name. One key advantage of domain-based routing is performance. Xray can make an immediate decision based on the hostname without waiting for a DNS lookup. Let's set this up so that ifconfig.me domain goes through the shadow.dat proxy, ipinfo.io goes through the shadowNL proxy, and everything else goes direct. First, I will go to the Outbounds tab and add 2 new outbounds. I will start with the direct connection to the internet. This requires its own outbound. So I will click Add Outbound, select the Freedom Protocol and set the tag to direct. Next, I will add a black hole outbound and tag it block. As you might expect, any traffic marked with this tag will be blocked. Now let's move on to the routing rules. I will edit the first rule. I'm going to remove the inbound tag, since we are not using it anymore, and add ifconfig.me as the domain. Next, I will edit the second rule. I will remove the inbound tag there as well and set the domain to ipinfo.io. From now on, whenever the proxy receives a request for a domain containing ifconfig.me, it will go through the shadow.dat proxy, and requests for ipinfo.io will go through the shadowNL proxy. Keep in mind that this is a partial match, so www.ifconfig.me will match too. If you want an exact match, you need to prefix the domain with full colon, like this. Now, if you want everything else to go direct, I will add a catch-all rule at the end. The easiest way to do this is by selecting TCP/UDP, since essentially all traffic falls into this category. Let's set the tag to direct. Just keep in mind that this rule has to be last, because routing rules are processed in order. Okay, I will save the configuration and restart Xray. Now let's test the setup. First, I will call ifconfig.me through this proxy. Okay, that's going out via the shadow.dat proxy. Next, I will call ipinfo.io. Okay, this time it's going out via shadowNL proxy. And finally, I will try check IP amazonaws.com. This one goes out directly. Let's switch gears and configure something a bit more complex. I want traffic to Google to go through the shadow.dat proxy, all Facebook traffic to go through shadowNL proxy, all Cloudflare traffic to go direct, and on top of that, I want to block all @related domains. I could start by editing the first rule and setting the domain to google.com. But that raises a question. What about all the regional Google domains? And what about YouTube? Luckily, Xray comes with a precompiled database of domains and IP addresses. This data is stored in the geosite.dat binary file. I will use the v2.dat tool to unpack it. First, I will create a folder and run the v2.unpack command to extract the data from the geosite.dat file. Now, if we go to the geosite folder and listed contents, we'll see a list of files, each containing domains grouped by categories. For example, if I open geosite Google, we can see all the domains owned by Google. Some entries start with full colon, which means they require an exact match. Others don't, which means they match partially, and some entries are regular expressions. So if we want to match all Google domains, we can simply enter geosite, colon, and the category name in the domain field. Xray will then match all of those domains and route the traffic through the shadow.dat proxy. Next, we'll search for the Facebook category. Here we can see all the domains owned by Facebook. Let's edit our second rule. In the domain field, I will enter geosite, Facebook. What about Cloudflare domains? Luckily, there's a category for that in the geosite.dat file as well. All other domains, including Cloudflare, would be matched by catch-all rule at the bottom. However, just for demo, I will add a new rule. Let's set the domain to geosite:/Cloudflare to match all Cloudflare domains and set it to go directly. Let me move the catch-all rule to be at the end, as rules are evaluated in order. Finally, we want to block ads. The category ads_all file contains over 145,000 domains, and we can use it to block all ad traffic at the proxy level. Let's add a new rule. I will set the domain to geosite:/category ads_all and set the outbound tag to block. I will move this rule to the top, since rules are processed top-down and I want to catch ad traffic early. To test it, I will enable access logging, save the configuration and restart Xray. Now let's open access log to see what's being blocked. I will open a browser that uses our Xray proxy. First, let's go to google.com. As you can see, Google traffic was routed via our shadowsocks proxy, and our access log confirms that. Next, I will open facebook.com. As expected, the traffic was sent through the shadowNL proxy. Now let's try cloudflare.com. This time traffic goes directly, just as the rule specifies. Lastly, I will go to weather.com to test the ad blocker. If we check access log, we can see ad domains being blocked. To sum up, using geosite.dat allows you to block ads at the proxy level, implement split tunneling, keep domestic traffic local while proxying foreign or specific traffic, and have granular control over which domains or categories are blocked, sent through an encrypted tunnel or connected directly. Keep in mind, the geosite.dat file is maintained externally and is updated almost daily. It's a community-maintained database. And just so we are clear, you don't need to unpack the geosite.dat file to use it. It comes bundled with Xray, so you can start using the categories right away. I just unpack it here to show you what's inside. Now that you've mastered routing by domain using Geosite, let's talk about IP addresses. Similar to the domain database, Xray also includes geoip. This is a binary file that contains thousands of IP ranges categorized by country. Let's copy the file from Xray and create a folder for it. If we unpack it, we'll get one file per country. When I open any of these files, I can see a list of all the network ranges that belong to that specific country. Now, in our routing rules, we can use this to say, if the destination IP belongs to my home country, go direct. If it's a foreign IP, use the proxy. This approach is much faster than checking against millions of domains. But there's a catch. To know the IP address of a website, Xray first has to perform a DNS lookup. When we were routing purely by domain name and the client connected to Xray using HTTP or HTTPS, the domain name was already included in the connect request. That meant the local Xray didn't need to resolve DNS at all. Instead, Xray simply forwarded the traffic to the next proxy in the chain, and that proxy handled DNS resolution. Of course, if the outbound is direct, then Xray becomes the exit node and does need to resolve the DNS. But when forwarding traffic to another proxy, DNS resolution isn't required locally. Now, to use geoip, our Xray must resolve the domain name into an IP address. There's a few ways to do this. The first option is to use the system resolver. If it's running over HTTPS or TLS and isn't blocked, that may work fine. Another option is to use remote DNS. In the Xray configuration, I can define an external DNS server like Cloudflare DNS and then tell Xray, if a rule requires an IP address, don't use the local system resolver. Instead, send the DNS request through a proxy outbound to a trusted server. Let's do that now. I will go to DNS section and enable DNS. DNS traffic is automatically tagged with the DNS inbound tag. Next, I will add a new DNS resolver. Then in the routing section, I will add a rule that sends traffic tagged as DNS inbound through the shadowsocks proxy. I will place this rule at the top. I will also change the DNS strategy to IP on demand. This option is smart. It tells Xray, try to route using the domain name first. Only if you hit a rule that requires an IP address, like a geoip rule, then resolve DNS. We'll cover DNS strategies and rules in more detail in a dedicated DNS video. Next, I will add a rule to keep all local traffic off the proxy. There's a dedicated geoip category that covers non-globally routable IP ranges, and we'll use that for this purpose. Let's add new rule. I will set the IP to geoip:private and set the outbound to direct. Next, I will add another rule so that traffic to Polish sites also goes directly. Just for demo purposes, let's block everything else. To do that, I will change the catch-all rule to block. Now I will save the configuration and restart Xray. Let's test the setup. First, we'll watch Xray's access log. Now let's confirm that private IP ranges bypass the proxy. To test this, I will SSH into a server on my local network, but I will force the connection to go through the proxy. Success! Traffic to private IP ranges stays local. Now, let's try connecting to a site that's not on our allow list. As expected, the connection is blocked. It matches the catch-all block rule. Next, let's see the geoip match in action. I will open a local Polish site. As you can see, the domain itself isn't on the allow list, but because the IP address belongs to geoip:/pl, the traffic is allowed and goes direct. By combining geosite for known domains and geoip for everything else based on location, you get a highly efficient and resilient traffic management setup. This approach strikes a great balance between performance, privacy, and your specific censorship or routing requirements. Today we transformed Xray from a simple encrypted tunnel into an intelligent traffic controller. Think about what we've built. We can route Google through Germany, Facebook through Netherlands, keep local traffic direct, block ads at the proxy level, and handle DNS requests securely through encrypted channels. Every decision is deliberate. Every connection follows rules you define. But here's what really matters. Your traffic looks human. No single encrypted stream, no constant tunnel activity. Instead, some traffic goes direct, some goes through proxies, different protocols, different timings, different destinations. To deep packet inspection systems, you are just another person browsing the web. That's not an accident, that's by design. This is Xray's real superpower. Not just encryption, but intelligent traffic distribution that defeats pattern analysis. The firewall sees normal behavior because you've engineered normal behavior. In the next video, we'll dive into UDP proxy because HTTP proxies can't handle gaming traffic, VoIP or WebRTC. We'll also explore DNS in depth, preventing leaks, configuring split DNS routing and handling DNS poisoning. Because as you've seen today, DNS isn't just a lookup service. It's a critical part of your routing decisions. Until then, experiment with these routing rules. Start simple, then add complexity, and remember, the goal isn't to hide everything behind the proxy. The goal is to look like you are not hiding anything at all. See you in the next one.